Welcome everyone, my name is Dan Fernando and in this video I'll be focusing solely on a particular concept in physics known as specific latent heat. The learning objectives are 1. To know the definition of specific latent heat and the ideas behind it. 2. Calculate the energy changes taking place when a substance changes state. Success criteria. By the end of this video, you should be able to distinguish between specific latent heat and specific heat capacity. Second, you should be able to recall and use the equation energy is equal to mass into specific latent heat. First of all, before we dive straight into our lesson, let us recall the basic concepts. As we know, when we heat a substance, the particles gain energy, leading to an increase in kinetic energy or even internal energy, and hence a rise in temperature. Nonetheless, the whole point of this video is that there is an exception to this concept, and that is when there is a change in state. For example, take a look at this heating curve. When a substance is changing state, for example at the melting point or even the boiling point, the energy provided is being used to weaken or break the forces rather than increasing the particle's kinetic energy, hence leading to a change in state. This is why we do not observe a rise in temperature when a substance is changing state. This same principle applies if we look at a cooling curve. Over here, the state changes involves the formation of new bonds rather than breaking the bonds, and the temperature does not change but rather remains constant throughout till the end of the change in state. Now, moving on to the main concept. What is the difference between specific latent heat and specific heat capacity? The term specific latent heat refers to when the exact amount of energy that is required to change the state of a substance is known, while the temperature remains the same or constant, and this depends on two things. 1. The type of substance, and 2. The amount of substance. Whereas the term specific heat capacity refers to the energy that is required to raise the temperature of a mass of a given substance by 1 degree. Hence, there is a change in temperature when it comes to specific heat capacity, but no change in temperature in specific latent heat. The definition of specific latent heat is that it refers to the energy required to change 1 kilogram of a particular substance from one state to another without a change in its temperature. There are two types of specific latent heat. 1. Specific latent heat of fusion, where this is the energy change when a substance changes between a solid and a liquid. 2. The specific latent heat of vaporization, and as the name suggests, this is the energy change when a substance changes between a liquid and a gas. The last thing we need to look at is the equation for specific latent heat, which says that the energy required or released is equal to the mass times the specific latent heat, and this is represented by E is equal to m into L. In order to make it easier to remember, you could refer to this triangle, where E is the energy required or released in joules, m is the mass in kilograms, and L is the specific latent heat, be either fusion or vaporization, which is in joules per kilogram. Now let us test what we have learned so far. Question number 1. State what is meant by specific latent heat of fusion, melting of a substance. Question number 2. Ice cubes of total mass 70 grams and at 0 degrees Celsius are put into a drink of lemonade of mass 300 grams. All the ice melts as 23,500 joules of thermal energy transfers from the lemonade to the ice. The final temperature of the drink is 0 degrees Celsius. Calculate the specific latent heat of fusion for ice. You could pause this video and note down the answers on a separate piece of paper. Resume this video once you're done. Displayed are the answers. 1. It is the energy required to change 1 kilogram of the state of a substance from a solid to a liquid at constant temperature. Now notice that the important keywords are highlighted, which is 1 kilogram of the state, and the second part is constant temperature. For the second question, since E is equal to m into L, we could rearrange and find out L. L is equal to E upon m, where when we refer to this triangle and when substituted with values, we get E is equal to 23,500 and m is 70 grams. hence leads to the answer 336 joules per gram or 340 joules per gram if rounded off. And if the answer is in joules per kilogram, then it should be 335,714 joules per kg. Some further practice. A 150 gram block of ice at 0 degrees Celsius is placed in the oven. The input power of the oven is 1100 watts. The energy absorbed by the block is 65% of the input energy. Calculate the time taken to melt the ice to water at 0 degrees Celsius. The specific latent heat of fusion of ice is 330 joules per gram. Pause this video and note down the answer on a separate piece of paper. Once you're done, you may continue. This is the answer. So first you need to find the energy absorbed. So this is found by E is equal to m into L, or 150 times 330, where we get 49,500 joules, or if you round it off, 50,000 joules. So as we know, energy transformed is equal to power into time. Therefore we can replace E with power into time. So P times T is equal to 49,500, and since the 65% of power is given, we can substitute and write it as 0.65 times 1100 T is equal to 49,500, and when we further calculate, we can find out T. So 715 T is equal to 49,500, and T is equal to 69 seconds. Over here, you do not have to change the mass in grams to kilograms, as the specific latent heat is also given in joules per gram instead of joules per kg. So it is not required to change the unit. Fourth question. The specific latent heat of vaporization of water is 2.3 times 10 to the power 6 joules per kg. Thermal energy is supplied to boiling water in a kettle at the rate of 460 watts. Calculate the mass of water that is boiled away in 180 seconds. So power into time is equal to m into L. We just referred to this in the previous question. 460 times 180 is equal to m times 2.3 into 10 to the power 6. So in this case, just replace all the variables with the values we have and solve for m, which you get it as 0.036 kilograms or 36 grams. The last question. The mass of the ice on an ice hockey rink is 51,000 kg. To form the ice, water at 0 degrees Celsius was poured onto the floor of the rink and then frozen. The specific latent heat of fusion of ice is 3.3 times 10 to the power 5 joules per kg. Calculate the quantity of energy removed from the water to form this ice at 0 degrees Celsius. So over here we are supposed to find the quantity of energy. So pause this video and note down the answer on the separate piece of paper. Once you're done, you may continue. So over here we're supposed to find the energy. So in order to find the energy, we know that E is equal to m into L. So E is equal to, m is given as 51,000. So 51,000 times L, which is the specific latent heat, is 3.3 times 10 to the power 5. So 51,000 times 3.3 into 10 to the power 5 will give you 1.7 into 10 to the power 10 joules. And this is the answer for the energy required. This is the end of the video, and I hope you have found this video helpful, and also that now you're able to finally understand all about specific latent heat. And allow me to end this video with some thoughtful words. Don't study to earn, study to learn. What you learn today is what you will become tomorrow.